Hello everyone, and thank you for joining us for the final webinar of Cisco CCNA V3, a short course presented by IT Masters on behalf of the Information Technology Professionals Association, or ITPA. My name is Guy Coward and I'll be your MC tonight, and your mentor of course is Matt Constable, who you'll hear from shortly. As always, before we begin, just some housekeeping, beginning with Zoom functions. We ask that you direct questions related to course material to the Q&A section and direct your administrative questions to the chat function. And also feel free to chat amongst yourselves using the chat to all panelists and attendees throughout the webinar. We think it's a really useful tool. On the exam, the short course exam I should say, next week from the 18th, the exam will be available to students. You'll have a full 8 days until 11:59 p.m. Australian Eastern Daylight Time on the 25th of October to complete it. You're required to complete all participation hurdle quizzes before you can access the exam and earn your certification. Those are the weekly quizzes that we've set. Just a word on the second week's quiz. Due to some confusion with one of the questions on the second week's quiz, that quiz will not be a hurdle requirement, but it'll still be available. Still yet to fix the question on that one, but I'll do that after this webinar. The exam can be completed any time before the 25th of October, and the quizzes can be done up until that time, but we recommend not leaving this until the last moment because you'll not be able to sit the exam without having completed the quizzes, and if there's any technical issues, we won't really be able to help you unless you get in touch with us before the exam period finishes. The exam consists of 40 multiple choice questions, which you will have 1 hour to complete. Please note that the exam can only be attempted once, unlike the other quizzes. Therefore, do not attempt the exam until you're certain you are ready, or as ready as you are likely to get. A reminder email will be sent out, and if you have any technical difficulties in the examination period, please email us at shortcourses@itmasters.edu.au as soon as possible. I'll post that email into the chat soon. For more information, you can read the How Do I Qualify for a Certificate link in the short course website. And once you've completed the course, we'd really appreciate if you took a couple extra minutes to complete the course satisfaction survey and for this short course only, a Zoom feedback survey, both found at the bottom of the IT Masters course page underneath the course content. These quizzes contain a few questions related to the short course and to the Zoom functionality, and they'll take only a few minutes. Your answers are anonymous and will be reviewed at the conclusion of the short course by myself and a couple of the other IT Master short course team as part of our improvement strategy. Your feedback is really valuable and will help us make future courses better, so please do get involved in that. Also on the short course page, there's some information for those interested in further study, but for those interested in tonight's lecture, I'll just hand you over to Matt Constable now.
Thanks, Guy. Thanks for the intro as ever, my friend, and that spiel about the exam, that's fantastic. Just one question I will answer firstly, sort of popped up from Doug, the first one that popped up about Cisco licensing. No, we're not going to cover anything around that. That's a discussion for a very different time. So there's none of that you'll need to know for the CCNA exam. But if I can direct you to Cisco's support website, so just www.cisco.com. If you log in with your user account, which you should have created as part of the first steps in the first week for this course, you will find plenty of information being able to answer those questions that you're talking about there. But basically, there's security feature sets, slightly different. So you just need to jump on Cisco's website and they will be able to provide you with all the information regarding that. Okay, so welcome tonight everyone to our final session. So you'll have noticed that the course outline talks about a whole heap of things, and as normal we're going to drill down on the more important things that you need to be across. I'm also going to talk a little bit, if we've got time, hopefully we will, well I'm sure we will, I'll make time. We'll talk a little bit about quality of service at the end because there was a specific question about that last week that I'd like to be able to answer for people. So have a look at that, and then right at the very end, I will talk a little bit about the real Cisco certification exams rather than the exam for this course, which is what Guy was just talking about. So let's move on to get through these slides, and then we can look at asking or answering all the questions you may have at the end. So tonight we're going to look at some infrastructure security components and some basic security thoughts, and then specifically look at access lists. They're the main bread and butter for a network engineer in terms of security, and the things that they'll really focus on in the CCNA exam. And then a little bit about some infrastructure management. So that's again focusing more on the security of hardening routers and some of the services and some of the command sets that you will use to keep your routers and switches nice and secure. So security 101, why do we need network security? Just bear with me for a sec while I pop that up so I can see where I'm going. Right, good. Why do we need network security? Pretty obvious really, to stop people from getting access to things that they shouldn't have. Now, whether that's people on the inside of your network or people coming from the outside of your network in, you want to be able to secure your network so that only those users or authorized users have access to the resources that they need when they need it with the performance requirements that they need. Secure networks are moving targets. So the more secure your network is, the harder it is to penetrate. As you keep things up to date, as your security is a living, breathing thing. So what is good, what is secure today may not be secure in 3 weeks' time, in 3 months' time, in 2 years' time, whatever the case may be, whatever timeline you're looking at. And so that whole point of keeping security moving all the time is really important in making sure that your overall network is nice and secure from whoever it is that's trying to get access to things they shouldn't. And clearly it makes networks harder to bring down, whatever that means. So whether that's remove a network off the air so people can't access it at all, or whether it's just to get in, steal some information, or get in and piggyback off that to go somewhere else. Security attacks and breaches are becoming more common and easier to perform, and tools, the tools available for these sorts of attacks are many and varied and don't necessarily require a lot of expertise to run. So just a quick little diagram here, sources of breaches around a place. So they can come from external, outside the firewall. They can come from illegal content, intrusion, denial of service, and all these things. Notice everything's coming from the internet. Okay, most of the time we think about attacks as coming from the internet, but that's not always the case. A lot of attacks can come from the inside as well, and often they're harder to, first of all, even notice that they're going on, but they're also harder to defend against because there's that implicit level of trust on the inside of your network where people are expected to be able to have access to these resources and facilities, and if they do the wrong thing with them, then that can become more difficult to track. And so potentially internal attacks can be more devastating than external. Network attacks are constantly evolving, and we've got to keep our security up to date and agile in order to be able to deflect those attacks. In general principles, security is reactive. An attack, there are heuristics around security, and there are tools available that make security proactive in a sense, and there's policies and procedures that you can put in place, but often security is reactive. So as new attacks, as new viruses, as new Trojans, or whatever the case may be, start to be designed and are released in the wild, then security has to react to that. They have to wait until new attacks are released before vendors can develop a fix for it in many ways. Attacks are becoming more costly for companies as the reliance on technology grows. So we know now that we certainly rely on our technology and our infrastructure much more than we did, say, 10 or 15 years ago. I remember years ago working for a bank, and if the computer systems went down, didn't matter. They had paper-based ways of keeping things going. So the customers could come in and just do things manually on a deposit slip or a withdrawal slip, and the whole process could keep going. Nowadays, that's not the case with the vast majority of banks. So once their IT systems go down, if they're completely out, then they've really got to close the branch, and they can't do a whole lot other than give advice, but they certainly can't dispense money, which is obviously a primary consideration for a bank. It's interesting that and this comes from a number of sources, so I can't give you a definitive reference on this one, but 60 to 80% of attacks come from the inside. And this is because of that, as I said before, that implicit access that people have to the systems from an internal side. But it's also related to the knowledge that workers have about the network that they're always on. So they know about the processes and procedures and the mechanisms that are in place to protect the systems, and they know ways around them as well. So knowledge, access, and the fact that things are generally less protected on the inside than they are on the outside means that there's much more opportunity for attacks to occur on the inside. Now, that doesn't mean that someone's going to take a whole network down. So an attack could be something as simple as misappropriating a document that they shouldn't have access to, or using some information internal to the company in an inappropriate way. So it can be something simple like that. It's still a security breach with respect to the network. So the main goals of security that we need to address in any secure system, but particularly it equally applies to what we're doing here in this course, is we have what's called the famous CIA triad, which hopefully most of you will have heard of. The CIA triad is made up of confidentiality, integrity, and availability. So confidentiality is merely the ability to keep data private, to keep what you want to keep secret as secret. So not handing it around, not letting unauthorized people access it. Integrity is about keeping the data unchanged so that someone doesn't get into your network and alter a whole heap of your information or corrupt your information. So that's maintain the integrity. And of course, availability is making sure that your network is always up, or up when it is needed by your customers or your clients or your users, okay, to make sure that they've got access to whatever they need access to. So in terms of vulnerabilities are weaknesses that can be leveraged by attacks or attackers, and they exist everywhere. Every network will have vulnerabilities, and that's why, putting a security hat more firmly on just for the minute, vulnerability scanning and penetration testing are so important, particularly in the network environment. So vulnerability scanning is about scanning your system to determine what weaknesses are there, and then the penetration testing is about exploiting those weaknesses to see how far you can get into the network, how much damage you can cause. And those vulnerabilities exist in any network. There is no 100% completely secure network. And it's our job as network people and security people to try and keep those vulnerabilities as manageable as possible. There's risk attached to a level of simplicity of the exploit to a vulnerability. So the more simple a vulnerability is, the higher the risk, in a nutshell. So who attacks us? All these guys here, and that's obviously not exhaustive. So I'm not going to read through those and go through those in detail, because we're talking about networking security, not security primarily. But you can see from that there's a lot of different people attacking from a lot of different angles. Additionally, they have a lot of different motives, reasons for attacking, and they're just some of them. There could be others, well, there are many others. But as I said, we're focusing on the networking. In terms of attacks, there's scamming, unauthorized access, theft, all those famous network-based attacks, denial of service, distributed denial of service, which everyone always freaks out about, worries about, blackmail, social engineering. There's all sorts of man-in-the-middle attacks, lots of different things that can be attacked. Now, lots of different ways to attack. The important thing is to remember that as a network person only, if you're a network administrator, your responsibility has only goes a certain way, a certain distance. After that, you need to hand off to other IT professionals, security team members, mid-range services members, whoever else can assist in building a defense in-depth strategy, which perfectly segues into this, what we're going to talk about. So the whole idea of defense in depth is that it's a design philosophy that promotes a layered security architecture. So you have a number of different defensive components which protect against multiple types of attacks. And these defenses all overlap with each other. So there's multiple components to deal with each set or class of attacks, if you like. The value of the asset that you're trying to protect, so whether that's intellectual property, whether it's customer information, whether it's medical information, whether it's money, whether it's nuclear launch codes, whatever it is, the value of that asset that you're protecting will determine the level of security that you apply to it. Okay, there's always got to be that that balance between being completely open and completely closed and usability. So there's that security continuum where at one end you have everyone has access, everyone can use. At the other end you have no one has access, no one can use. The balance has to be somewhere in between, between security and the actual use of your system. And of course, things like strong encryption using PICO, AES are certainly part of a defense in depth strategy. Now that's an old time example of defense in depth. As a security strategy, we have a large castle with multiple walls, with presumably the boss hog sitting in the middle there, protected by multiple walls, multiple levels of defense with a moat outside, mountain ranges all around. So that's a defense in depth concept. It's not a new concept. It's been around for literally thousands of years. People have been applying it practically like this in a physical sense for many thousands of years. So it's just taking that military concept and applying it to security architecture, IT security architecture. So if we just look quickly at some examples of the sort of security we can look at, here we've got a diagram which shows us very simple security. We have a single firewall, a DMZ off to the side with the email and web server live. We have an internal router on one side with a corporate trusted network. We have the nasty big wide web on the other side. Very simple, protects against lots of different things, but there's also a bucket load of things that won't protect against. And it's also limited functionality. You've got some PCs behind, some servers in the DMZ, that's it. None of the fancy features that we expect now of our networks, like voice over IP and wireless and all those sorts of things. We then have this diagram, which is a little bit more complex, where we have a data center, we have a district office, we have some school sites, we have a link off to the internet, and we have a core and distribution layer. So if we look here, we have our access layer, we have our core and distribution layer here. We've got some wireless, we've got some NAC, network admission control server. We have a data center which has got some video surveillance, some ACS appliances, some SRST video gateways. So we've got video and voice in there. We've got Cisco Call Manager, basically Unified Communications Manager. We have some email servers. We've got some ASAs. We've got some IPS. Obviously, you can clearly see this is a Cisco diagram. And then at the branch offices, we have our wireless LAN controllers. We've got a service provided managed Metro Ethernet core. So there's lots of different stuff happening there, but you can see there's multiple layers of security. There's multiple firewalls, there's network admission, there's IPS, there's email security, there's web security. There's lots of different layers there. So that's a little bit more complex, obviously, than our first example. If we look at this example, this is what I would class a ridiculous example, where we have, this is at the other end of the scale. This is at the crazy end of the scale, the paranoid end of the scale, where we've got all sorts of devices with all sorts of SSL links and all sorts of stuff happening backwards and forwards, multiple devices everywhere doing lots of things. Can get really, really complex. Yeah, sure, might provide lots of security, but remember that the more complex you make something, the easier it is for someone to hide within that complexity. So more complex, throwing more resources at it is not always the answer. So the important things about network security is that firstly, it must be agile. It must be able to move with the times very quickly. It must be manageable and upgradable, changeable very quickly. It must be multi-directional. So that is, it needs to protect from stuff coming from the outside and stuff coming from the inside, attacks from both directions. We can't just assume that the bad people only exist outside our network. It must be multifaceted. So what we mean by that is it must have lots of different components to it. So we've got our basic access list, for example, like in that complex diagram there. We had our routers, we had our firewalls, we had IPS, we had wireless LAN controllers, we had some web security, we had some email security. So looking at lots of different security viewpoints, coming from lots of different security viewpoints. Clearly, it has to be maintained. Now, the only thing worse than no security is having security that isn't well maintained, because all it does is lull you into that false sense of security. At least if you have no security, at least you know something is going to happen. So you keep an eye out for it. You're expecting it to happen. When you have poorly maintained security, you're assuming that everything's, apples, everything's really good, and it's not, nothing's going to happen. But it lulls you into that false sense of security. So it must be maintained. And clearly it must be scalable. So it's no point putting in, a firewall that can hold 2 meg connections if eventually within the next 6 months you're going to have trying to put 100 meg or 200 meg worth of connections through it. So you've got to look at that in advance. Don't put in what you need today, put in what you need tomorrow, so to speak. So Cisco have this model called Cisco Safe, which is their all-encompassing model of security, and employs what is called game theory, and that is that it provides building blocks that are focused on specific threats to your particular network architecture, whatever those threats may be. And it's dependent on your network. You would have heard me say numerous times, the answer to any engineering question is usually it depends on what you're trying to achieve. So the game theory also provides best practices for dealing with those particular threats through that building block approach. So Cisco takes these simple concepts and applies them to a complex problem. They build all these different building blocks and put them together to form a metaphorical wall, which then applies lots of little simple building blocks to a very complex problem, which is, of course, network security. But it's not a single answer. Cisco Safe is not a single answer. They don't pretend that it is. It's certainly not. It is part of a defense in-depth approach. Okay, but it's something that you need to be aware. You need to be aware of these ideas in order to be able to go into the CCNA exam fully prepared for the security viewpoint. Even though it's not a security specific exam, obviously there's security CCNA for that in terms of the syntax and the feature sets and the different devices. But there's still that, from a security viewpoint in the CCNA route switch, there is still that consideration of security that you need to have. So for CCNA, the basic tools really are access lists. And the idea, the whole concept is to stop threats before they get in. So therefore, stopping things at an access layer. Okay, and part of that also relates to authentication systems as well, which obviously allows access to those who should have access and prevents anyone else from getting in. But access lists are where it's at. That's our bread and butter for the CCNA route switch. So network engineers bread and butter. We can use them for classification, so quality of service, dial on demand, policy routing, but then the one we really want to drill down on tonight is access and filtering. So yes, you can use them for classification and quality of service. Yes, you can use them to bring up a dial on demand interface. Yes, you can use them for policy routing. And there's a couple other things you can use them for too, which are outside the scope of CCNA. But access filtering is a primary one we want to look at. So what is an ACL? An ACL is simply an ordered list of statements that determines how traffic passing over a link is going to be handled. Simple as that. So if we have a quick look at this diagram here, we see this ACL on router 2 is, sorry, I'll turn that highlighter on. This ACL on router 2 is allowing email and denying telnet. Now, clearly we haven't got the statements there, but that's the idea of the ACL there. For this ACL from router 3 going to the HR subnet, it's to permit HR access. And then you've got a couple of other ACLs that I'll let you look at in your own time. The point of it is that the ACL is just providing treatment. So it provides traffic treatment. So it could permit traffic or it could deny traffic. Don't always think of an ACL as being something that is deny only, because it certainly can be both. Okay, the primary purpose that we want to look at is packet filtering. So in this case, filters are based on stated criteria. So that is criteria that you as a network engineer come up with, or maybe potentially security engineers that pass it on to you. But whatever the case is, this criteria is based on business traffic flows. What is going through your network? What are you trying to protect? How do you want to manage those traffic flows? So a good way, a nice analogy I like to use with it is, think of a packet filter as being a contact, like a contact center or a call center, where they have a rundown of procedures which tells a operator how to handle a call as it comes in. So you as a customer ring up, they have a script or a set of policies and procedures that they have to go through in order to handle your call depending on the question that you ask. An ACL is exactly the same way. It's just a set of policies or criteria that you set up in a certain order that tells the router how to treat traffic as it comes in depending on what type of traffic it is. So in this case, we're looking at routers, but they can also apply to layer 3 switches, which is basically a router anyway, as we know from our previous studies in previous weeks. But the router will act as a packet filter when it forwards or denies packets according to those filtering rules based on your criteria. So all an ACL is a sequential list of permit or deny statements, and each one of those statements is known as an access control entry. So an ACL is made up of ACEs. In terms of the operation of an ACL, so we have an inbound ACL and we can have an outbound ACL, and we'll talk a little bit about the requirements and rules around ACLs in a minute. But basically, an inbound ACL filters packets coming into a specific interface before they are routed. Okay, so it checks whether they're valid before it routes them. However, an outbound ACL filters packets after they are routed, regardless of which interface they came in on. So if you use an outbound ACL, routing will be performed first. If you use an inbound ACL, the ACL will be applied first. A really important thing to remember is that the last statement of an ACL is always an implicit deny. So even if you don't put a deny, say an IP deny any on the end of your ACL, it always exists. It is always there. It is just part of the built-in code. This statement is automatically inserted at the end of each ACL, even though it is not physically present. So even though you don't type it, it will still be there. The implicit deny will block all traffic. So unless traffic is explicitly permitted with a previous statement, when it gets to the end of the access list, if a packet hasn't been matched on any rule or entry in that access list, it will be dropped. That's it. So because of this, an ACL that does not have at least one permit statement will block all traffic. Okay, so don't get caught by that. Don't think that if you just put a ACL on your router and don't put any statements in, it's not going to block anything. It will actually block everything. So the default is to block everything. Really important that you remember that, because it's caught lots of people over the years in the CCNA exam. So types of ACLs, a couple of different types we'll look at. There's a third one as well, which is on the next slide, but basically standard ACLs and extended ACLs. So this here is an example of, so the top one here is an example of a simple ACL. Standard, access list 10, so we have a number always applied. So access list obviously is the first command to say we're setting up an access list. 10 is just the sequence number. We're going to permit traffic from this network. That's as simple as that. So standard ACLs will only filter IP packets based on the source address. That's it. Just source address. If you want to filter on source and destination, or a set of particular ports, for example, then you have to use an extended ACL. And in most cases, you'll use an extended ACL. Most of the time when I do ACLs, I will use standard ACLs if I'm wanting to say control access to the telnet lines on a router, the VTY lines or SSH. For everything else, for packets actually transiting through the router rather than destined for the router itself, I would use an extended ACL because it gives you a much higher level of granularity and control. So with an extended ACL, you can filter, so you can deny or permit packets based on a number of different things. So it can be any combination of these here: source and destination IP address, source and destination TCP UDP port numbers, protocol type, and protocol number. So when we say protocol type, so IP is a protocol type, okay? TCP and UDP are a subtype of IP, but a protocol type may also be IPX, for example, or AppleTalk, or various routing protocols that don't actually use IP as such, but they use their own protocol. And there's various examples of that, which I think we have a look at just shortly. Okay, there's also numbered and named ACLs. So a numbered ACL is where you assign a number based on the protocol, on which protocol you want filtered. So the numbered ACL, which are really just, they're just versions of standard ACLs and extended ACLs. So if we look at the previous slide, you'll see here we've got access list 10, access list 103, that applies to these numbered ACL here. So if we use a number 1 to 99 or 1,300 to 1,999, that designates that whatever follows up is a standard ACL statement. So it can only be based on the source IP. However, if we're doing extended ACLs, these are the numbers that we'd use here. So it's important that you know these numbers, some of these numbers, and there's other ranges as well. There's a resource up on the Moodle website which will help guide you through that. So it's important that you know that if you want to do a standard IP ACL, you don't use number 100 or 101 or 200 or 300, because that's then an extended ACL. So the router is expecting more information from you in order to be able to create that ACL. A named ACL, really just, instead of using a number, use a name. And that's nice and easy for us as human beings, because names are often more meaningful as to numbers, but that's really the only difference there. But the actual syntax underneath it is exactly the same regardless. In terms of the permitting and deny statements, the protocols, the destination and source networks, subnet masks, port numbers, all that sort of jazz. So some general ACL guidelines that you need to understand for the exam, for the real Cisco exam, not the course exam, but the real Cisco exam. If you've got, you use ACLs in firewall routers positioned between your internal network and external network, such as the internet. So that's basically saying you can use an ACL like a firewall rule set on your router if you wanted to. Okay, you can use ACLs on a router positioned between two parts of your network to control traffic entering or exiting a specific part of your internal network. So these ACLs can exist anywhere. They can exist on your internal network, they can exist on the internet facing, they can exist facing an extranet, they can exist between a couple of different departments, say R&D and HR, or R&D and some, rest of the network. They can be used anywhere. They don't have to just be used as a construct to stop nasties from the outside world coming in. ACLs on border routers, that is routers situated at the edge of your networks. So that could be a router that interfaces between you and your service provider, or you and an extranet partner. So it might not actually have a link that transits the internet, but it could be a leased WAN line, or perhaps an MPLS cloud or something similar to that. You can also use ACLs on the routers there to protect access, as well as doing things like QoS, classification, policy routing, dial on demand, as we spoke about earlier. And configure ACLs for each network protocol configured on the border router interfaces. So if you're running IPX and you're running IP, then you would need to have an access list for each if you wanted to do that. So some further guidelines, and these are really important rules. These are really important rules. You can have one access control list per protocol, per direction, per interface. So that means if you've got a single interface that you want to protect, you can have an IP access list in the outbound direction, and you can have an IP access list in the inbound direction. But you can't have two going out, none coming in, or two going out, one coming in, or two going in both directions. You can only have one ACL per protocol, per direction, per interface. Okay, they're absolutely key guidelines that you need to memorize. Pretty straightforward, but they're important. If you don't understand that, then you'll get yourself in all sorts of trouble creating access lists. And this is, I guess, where the complexity of developing an access list can arise in trying to cram everything that you want to protect, either permit or deny, into a single access list. It's a real skill that you need to develop over time. And the only thing that will help you with that is certainly practice. No, you can't just read a book. You can't be just given the answer. You need to actually just sit down and write the things. So basically, have a look at Cisco's website, pick a type access list that you want to use, look at the syntax that you have to use, and then just sit down and brainstorm, what traffic do I want to protect, what are the source networks, what are the source IP addresses, what are the destination IP addresses, and just sit down and work it out. Trial and error, particularly when you're new at it, is the best way to learn. Just give it a go. So every ACL, of course, needs to be placed where it has the greatest impact on efficiency. So not just in terms of security, but also in terms of network throughput. The basic rules of thumb are extended ACLs should be located as close as possible to the source of the traffic that is filtered. Okay, to the extended ACLs closest to the source of the traffic. However, because standard ACLs don't specify destination addresses, you need to place them as close to the destination as possible. Okay, so this is where, now this may seem a little bit confusing if you're just thinking about it from a internet-facing perspective. But if you now tweak this and think about it from an internal network perspective, so you've got a router somewhere on the inside of your network that is protecting or separating different departments from each other, then this makes a lot more sense and it's easier to understand. So extended ACLs, close as possible to the source of the traffic, because what you're doing is you're blocking from specific sources, but you're blocking to specific destinations and ports. So there's more complexity in that, so you keep that closer to the source of the traffic to then enable that specific traffic to be knocked out before it even starts to transit across the network. So you're saving bandwidth. However, because with your standard ACLs, you don't get to block destination addresses. So it's no good putting them close to the source because you can't block on destinations, you can only block on sources. So while you may block some of the traffic that you actually do want to block, you may also block a lot of traffic that you don't want to block. So it's better to place the standard ACLs, which will only work on source addresses, close to the destination that you're trying to protect. So as traffic's coming through, when it gets to the last point, it's going to go, oh, okay, no, you can't go. Yes, that has an impact obviously on throughput across the network because you're allowing that network to transfer across, allowing that traffic to transfer across. But at the end of the day, that's a limitation of the ACL. It's a standard ACL. You can only block on source addresses. So it's very limited. And that's why in a lot of ways, extended ACLs are generally a better option because they give you that flexibility to place them closer to the source and therefore limit the amount of traffic that goes over your links. So placement of the ACL and therefore the type of ACL used may also depend on the extent of the network administrator's control. So how much control do you have over the network? How much control do you have over your traffic flow and the routers involved in that traffic flow? Can be related to the bandwidth of the networks involved. If you've got multi-gigabit or terabit bandwidth, then you might say, hey, who cares if a bit of extra bandwidth goes, a bit of extra traffic goes across. But if you've got really small WAN links, say 256, 128K WAN links, then every bit of bandwidth counts. And of course, the ease of configuration. Standard are easier to configure, but they're less feature rich, less useful in many cases. So standard ACL placement, so just have a quick look here. What we're trying to do is block all traffic, sorry, turn on the highlighter. And what we're trying to do is block all traffic from the network 192.168.10 going to 192.168.30. So in that case, if we're using a standard ACL, we're going to filter traffic as close to the source as possible. Pretty straightforward. So as close to the source network as possible. sorry, standard ACL as close to the destination network as possible. What am I saying? So you can see .10 network is over here. .30 network is over here. So we're placing our ACL somewhere in this way here. So we can either do it inbound on this interface, or we can do it outbound on that interface. So it doesn't really matter, but just remember that you've got that whole process of whether you want to route the traffic first and then block it in outbound, or you want to block it before you route it coming inbound. That's the difference there. But you can block it. These are not, don't necessarily block in both. This is an either or. You can block it here as it comes into router 3, or you can block it as it goes out of router 3. The only difference being, if you block it outbound, it's routed first, takes a little more processing power, a little more time. If you block it inbound, just cuts it off at the knees before it's routed. So that's the difference there. Extended ACL placement on the other hand, so in this case we just want to block FTP and telnet traffic from the .11 network to the .30 network. So .11's here. So we want to block, because we want to block specific traffic only, so FTP and telnet, but everything else is allowed, then the two places that we can add that access list are either inbound to router 1 or outbound on router 1. So same case applies, depends on whether you want to route it first and then block it, or whether you just want to block it. But the point is that because it's an extended ACL, it's blocking very specific traffic. We don't want to block all traffic, we just want to block FTP and telnet. So we need to apply that as close to the source as possible, so we get rid of that traffic before it even transits over the network. But it allows everything else through. So in this example, it might let through web traffic, it might let through SMTP, it might let through other file and print type services. So close to the source, extended ACL placement. So if we have a really quick look at the way we would configure them on a router, and I don't want to spend too much time on this because we've got the labs up on Moodle for you to really practice this stuff on. And as I said before, it's something that you really need to practice. I mean, I can sit here and drone on about access lists all night, and believe you me, I can. But it's not going to help you as much as sitting down and spending 15, 20 minutes, half an hour just practicing on the packet tracer labs. You get much more out of it. Hands-on is so important. While we provide you with lots of theory in these webinars, there's nothing. And I mean, I could get up a router here and I could start typing statements in, but it's still no different to just talking about it. Okay, what you guys need to do if you really want to pass the CCNA exam is get some hands-on, either on packet tracer or on some other lab, GNS3, or the numerous labs that are available out there on the internet, or hands-on on real hardware. And the more practice you will get, the better you will get at it. But it's important to understand conceptually where these access lists are going to be placed, to understand how traffic flows and how you're protecting your network. So if we configure, look at an example of how to configure a simple ACL. In this case, the basic, so we're in config mode on the router. Sorry, highlighter again. Config mode on the router, on router 1. We type in access list 1. So 1 indicates the standard access list, as we talked about the numbers before. We're going to permit IP traffic, because remember, we can only permit simple standard access list, only permit on source networks, and we're going to permit the 192.168.10 network to go to be permitted across that access list. We then have an ACL2 as an example, where we're permitting 192.168.10, but this time we've got a deny everything else there as well. Now notice there's no keyword on that, the deny any. It's just saying deny anything else. It's just assuming it's IP. Now what's the advantage of having an explicit deny statement on there? Because remember I said before that every access list has an implicit deny any at the end. So what's the advantage of having an explicit one where you actually typed it in? The advantage is that you can also set that to log. So it will, every time that particular rule is hit, it will log to the router's buffer, or it will log to your logging server if you've got one set up. The advantage of that is that you get to see what is being denied on your access list. Because in this case, because it's so simple, we're permitting traffic, but we're not denying anything. So it may be, you know, we might get a phone call from a user that might say, it's great, some of my traffic's getting through, but some of it's not. Can you have a look, please? And when you look, because you've got that explicit denying, it's logging that traffic. You can see what traffic is being denied and have a look at that. And based on the user's report, there may be some methodology or another entry that you can add to the access list that will help with that particular problem. So it's important that it's there. If that explicit deny is not there, then you don't get that option to look at what's been denied. And same as we said before, as close to the source as possible. We could equally have applied it inbound on the G01 interface as well. That would have been adequate as well. So order of operation, important to understand that access list statements are processed sequentially. So the order of which you write these statements is really, really important. So in other words, if, for example, like this one here is a really poor example. Access list 3, deny everything from that network. So it's denying all traffic from the network. And then the next entry is to permit that particular host, which resides on that same network. Sorry, highlighter. Sorry, guys. So we're blocking this network here, but then here we're permitting that host. Now that host will never actually be permitted ever because this statement above it blocks it. Simple as that. So the better way to do it would be to flick those statements around. So have the permit host 192.168.10.10 first, the deny afterwards. So that would explicitly match only traffic for 192.168.10.10, pass that through, and then everything else would be blocked, which is what the intent of that particular access list is. It's just that the statements are the wrong way around. And you can imagine that's an exceptionally simple access list with 2 statements. If you have an access list got 20, 30, 40, maybe more statements in it, it can get really, really confusing. And you can have, I've seen it many, many times where statements higher in the access list actually block valid traffic that is permitted lower down. And, you know, engineers get confused because they put a statement in which says, okay, well, this should be permitted, but it's not because it's blocked by something up above. The other corollary to that, I guess, is to say that when you add to an access list, when you add a statement to the access list, it is automatically put down to the bottom of the stack. So if you're writing a statement of access list that is going to be contraindicated by statements that are previous, then the best approach is to basically remove the whole access list, write it up in Notepad or Word or something, preferably Notepad. That's the network engineer's traditional tool of choice. Write it in an appropriate order and then paste it back into the configuration. Otherwise, you can get yourself in all sorts of trouble. So particularly for the CCNA exam, be really careful if you happen to get questions that ask you to write an access list for a simple task, and you may, just be careful that you put it in the correct order. Okay, now after an ACL is written, that's fantastic, brilliant, love it, fantastic. But it's absolutely useless until you apply it to an interface. And these are the command, this command here is the nomenclature for the command syntax to add an ACL to a particular interface. Remembering, of course, that you can apply it either inbound or outbound. It's pretty simple. So you've already written your access list. We go to the interface. Notice it's in interface command mode now, not in config command mode, interface command mode. And we type IP space access group, the access list number or the access list name. So that's what it's saying. So you either put number, so say number 10, or you put the access list name, say ACL underscore telnet or something. And then you apply it either in the in or the out direction. So you can't do both, got to be one or the other. And then to remove the ACL from the interface, all you need, same as everything in the Cisco world, to reverse the command, you just prepend it with the word no. And then it takes the command off. Nice and simple. And again, the more practice you can get with this on Packet Tracer Labs, on real equipment, the better you will be prepared for the CCNA exam. Please don't think you can go into the CCNA exam and blitz it easily without hands-on experience. Okay, you need to have some sort of hands-on experience, hence the ability to use the Packet Tracer Labs as part of this course. So if we look at an example here where we're denying a specific host, so access list 1 is a standard access list, so that means it's only going to block on source address, which means we have to have it located as close to the host, the source as possible. So in this case, so no access list 1, okay, they've taken it off. Then we're going access list 1, deny, and this is what I was saying before. If you're going to alter an access list, it's probably better that you delete it and recreate it altogether. Now there's a trick here that they haven't shown because they haven't yet applied the access group. I'll give you this tip because it may come up in the CCNA exam. If you are asked to edit an access list and that access list is already applied to an interface, if you run this command here, so you run this no access list 1 command, it will remove the access list. Yes, absolutely. However, that access list will be applied to that particular interface still. Okay, that command will still exist there. So if that particular access list is permitting really important traffic through it and you delete the access list, that traffic will then disappear. Okay, so that's a trick. The best thing, the process to actually follow would be to remove it from the interface first, then delete the access list, rewrite it, recreate it, and then reapply it. Okay, now clearly there are times when you will have to do that on the fly, but that is certainly not the recommendation. You would normally do that within a change window at the console of the router, in particular if the access list is providing you with access to that router. And I say that with hand on my heart because I was caught with it on at least one occasion in my life and was very embarrassed. So to apply the access list, we've written it. So it's denying the host 10.10, so this guy here. I turned that off. Why did I turn that off? And then it's permitting everything else. And then we go to interface G00. So we're now in interface mode and we apply that access list IP access group 1 in the inbound direction. So in that case, we're going to match on the access list before it gets routed, not after. Oops, turn that off. Okay, here's an example of editing some standard number ACLs. So just some, this is a recommended, this is actually a Cisco recommended step process. And where it says text editor here, my recommendation is to use Notepad. The reason I say Notepad is because it doesn't introduce any other extraneous characters into the text. Whereas if you use Word or WordPad or some other, whatever other word processor you use, it can sometimes add in carriage return line feeds where you may not want them and therefore generate unexpected results when you paste it back into your configuration. So I've got a configuration that exists. We do a show run config, which includes everything from access list 1. We see what we need to change. We change it in our text editor. So we've changed this host address from 99.10. We then go into configuration T. Now, interestingly, they haven't removed the access list, and there's the reason they wouldn't have done that, or well, the reason you might not do that is if you're connected to the console of the router, it's not going to affect access to the router. You can quickly run no access list 1 and then paste the access list in, and it will bang instantaneously be on. Within a very short period of time. It's not going to impact traffic too much. Is it a risk? Yes. Would I advise that you do it? Maybe. Depends on how much experience you've got. Depends on how confident you are that the ACL is not going to block access. But it's certainly something to keep in your mind. And then in this last box here, they're just running the show running config again, and it shows the result of the changes. So now we've changed this host from 99 to .10. Okay, using sequence numbers. So now, with an access list, you can also put in a sequence number. Okay, and all you really need to do that is to use this syntax here. So add the sequence number on to the beginning of the actual denial permit statement. The advantage of using sequence numbers is that it then allows you to remove and add statements at a particular spot in the access list without having to delete and recreate the whole access list as we just did in the previous example. So it allows you to insert things, insert statements on the fly. So, and you can see how they do that here. Another tip to look at and to think about is you'll notice that the numbers are 10 digits apart. So they're sequenced as 10, 20, 30, 40, 50, 60, so on by standard. And that's so if you want to, at some stage, you will be able to insert a statement in between two previous existing statements. So it gives you room to put in, you know, another 10 statements if you, or 9 statements if you wanted to do that. So you can put an 11, a 12, a 13, a 14, a 15, so on. Gives you that room for expansion. Or it gives you the room to put in a temporary rule and then delete it later on without having to reinvent the wheel. Standard name, ACLs, again, exactly the same process. It's just using the name instead of the number. That's all it is. So nothing different there. The actual syntax, the process, the procedure is exactly the same. To verify an ACL, basically two ways we can verify ACL. The first way, so shown here, using the show IP interface commands. That's to confirm that access lists are actually applied to an interface, applied to the interface. So in this case, we can see serial 000 has an outbound access list number 1. G00 has an outbound access list called no access. Great. So that shows us that our access lists are applied to our interfaces, because obviously that's the last step, that's the important part. We can have all the beautiful access lists we like in the world. If we don't apply them to interfaces, they're useless. Then lastly, we've got our show access lists or show IP access lists, and that will give us a readout of all the access lists that we currently have configured on the router. Doesn't tell you whether they're applied or not, but it will tell you what is configured on the particular router. And if you have logging enabled, it will actually show the match count for each access control entry within that ACL. And here's an example of it here. So if we have a look at show access list, here's an example just here in this second window here, which shows that this particular statement, deny 192.168.10.10, has had 8 matches, and this one down here has had 4 matches. Similarly, these guys have had 4 matches. So if we look at a more practical example now, just quickly, so verifying, so securing VTY lines. So securing the telnet lines or SSH lines on your router. Okay, so in this case, we've configured an access list, which is permit 192.168.10.0 /24, and we're denying everything else. And we can see that when we SSH, if we're SSHing from 10.10, we get a connection through. This is what we get. So if we're going from this particular host trying to connect to the router by SSH, we get our login prompt, we can enter our password, and then we're at the command prompt for the router. If, however, we come from this host, so 11.10, and try to SSH in, we can see from the access list that we only permit 10.0, anything from the 10.0 network, but we deny everything else. So 11 network denied, we basically get a connection refused. So go away, I don't want to talk to you. So that's the sort of output that you'll get with a really simple access list there. Okay, inbound ACL logic. Just quickly go through the logic, and I think these are the last couple of slides on ACLs, and then I'll answer some questions, and then we'll talk about the next part and get through that pretty quickly. So packets are tested against an inbound ACL if one exists before any routing occurs, okay? So we said that before. If an outbound packet matches an ACL statement with a permit, it is sent through to the routing process to be routed. If it matches an ACL statement with a deny, it is just dropped and not routed at all. If an inbound packet doesn't meet any of the statements, so it doesn't match any deny or permits, it's just implicitly denied and dropped without being routed. So that's because of that implicit deny at the end. Pretty simple. Outbound logic gets a little bit more complex, but not much. So in this case, with an outbound ACL, packets are first checked for a route before being sent to the outbound interface. If there is no route, then the packets are obviously dropped because we don't know the route, so go away, I'm dropping the traffic. If the outbound interface has no ACL, then the packets are just sent directly to that interface and off they go. If there is an ACL, it is tested, so the traffic is tested before being sent out. If the outbound packet matches the ACL statement with a permit, it's sent as normal. It doesn't have to go through the routing process. It's already done that, so off it goes. If it matches the deny statement, it's just dropped. And again, if it does not mention the ACL statements at all, so it doesn't permit or deny, then it's just implicitly denied and dropped. So you can see the only difference really is there is the routing is done beforehand, which means it takes a little bit more time, a little bit more complex, but still basically in the end does exactly the same job, just the routing process occurs before anything is batched. So again, probably inbound ACLs, inbound extended ACLs are probably more useful than outbound in many cases. But obviously it all comes back to that age-old answer. It depends on what you're trying to achieve. So without going into too much detail on IPv6 ACLs, because you won't be configuring any of those in the CCNA exam, but just a bit of interest knowledge for comparison. IPv4 ACLs, we have standard, so number to named, extended number to named. IPv6 ACLs, we have named only. Otherwise, they're similar in function to an IPv4 extended ACL. So not so much on the standard side, more extended, and they're only named, so you don't apply any numbers to them at all. So if we have a quick look at some of the comparisons, so V4 and V6 ACLs are very similar. There are three significant differences. When you apply an IPv6 ACL, we use the IPv6 traffic filter to command to perform the same function for IPv6 interfaces. So we don't use IP access group blah, we use IPv6 traffic filter and then the name of the traffic filter. There are no wildcard masks, so the prefix links is used to indicate how much of an IPv6 source or destination address should be matched. So it's based on prefix length, not wildcard masks. And then there's some additional default statements around neighbour discovery, so solicitations and advertisements. Because they're related specifically to IPv6 protocols. That's why they don't exist in IPv4. So if we have a look at a quick example, this is a topology, which I'll let you browse that in more detail later on, because there's other more important slides that we need to get to, and this is not something that you need to know a lot about, but it's there for your interest. We can see here's the difference between the application of the IPv6 access list. So we've got IPv6 traffic filter, the name, and then the direction. So in this case, it's an inbound direction. And then we have this example where it's denying FTP. So we have IPv6 access list, there's the name. We deny our TCP to that from that particular, from any network to that particular network with that prefix length equal FTP and FTP data. And then we're letting anything else through with that permit IPv6 any statement. And then we also need to apply that to the routed interface. So again, because IPv6 access lists are more akin or more comparable to IPv4 extended access lists, there's that recommendation that you apply them closer to the destination than the source. So configure and verify IPv6 ACLs. Again, just briefly on that, same sort of thing. They show IPv6 interface G00 will tell you whether an IPv6 access list is actually applied to that interface. And then if we do show access lists, it will show, this would also show IPv4 access list if they were to exist on this router. But in this case, it shows the access control list and the access control statements for that particular IPv6 access lists. Okay, so I'll go through and answer some of these questions, because the next section is getting onto the hardening and the management. So
Before you start on the questions in the Q&A section, we've got a question in the chat actually. Why do the
okay,
computers have a global address?
why do the what? Sorry.
The computers from a couple of slides ago have global addresses.
It's just an example. So they're just random addresses that have been put on the slide. So it's,
No worries.
yeah, that's a simple answer is it's just an example. So it's not, it's just an example to show the way it all hangs together. So that's, yeah, no trick to that. Okay, so other questions? Okay, that's not really a question. Defense in depth, would it also multi-layer security perimeters? Yes, so yeah, defense, yeah, absolutely. You can have multiple levels, multiple perimeters, absolutely. And that's an interesting question because, which I won't get too carried away with, I guess, because we want to keep it focused on CCNA, but the whole concept of a perimeter now is very different to what it once was. So the traditional version of perimeter is, protecting the inside network from the internet, but that's not the case anymore. A perimeter can extend to extranets to into your internal network around certain individual departments and certain individual subnets. So the perimeter is really a really fluid thing, really fluid. So it's almost like a river that winds around, creating little islands here and there. It's a very fluid thing. So, but defense in depth, absolutely no different to multi-layers of security. Having multiple encryption slow down network resources somewhat, but in today's world with lots of iron and lots of processing and memory power, not as much as certainly once was the case, but certainly in previous years that would have been a case. If you have too much, if you have a lot of encryption, it can slow down, but not really an issue nowadays, no. What is the number in access list number port IP subnet? So the number is just basically the label applied to that particular access list. So as I said before, some of those number ranges, which the resource is up on the Moodle site for you to have a look at, that will just designate whether it's a standard or a extended access list, and it's just a label for that access list. So think of it as like it being its name. A named ACL, can it be either standard or extended? It can, depending on the iOS. Current versions of iOS allow ACL, most current versions of iOS allow ACL, named ACLs to be standard or extended, yes. Why do you need an ACL rule for dynamic overload NAT and not for static NAT? Because static NAT is a one-to-one relationship. So you create the rule, if you like, within the actual NAT statement. Whereas for dynamic overload, you are matching potentially many other addresses. So you use an access list to do that. Dynamic and overload, you could also be matching from multiple subnets. Whereas static one-to-one NAT, it's one-to-one relationship between inside and outside address. So that's why you don't need a ACL for that. So good question. Why is the syntax create an ACL different to an applying an ACL? Well, because the access list itself is a creation. So access list is a command to create the actual access list. Access group is then referring to the application of a particular access list to that particular interface. So if you were to use the same command, it potentially, well, it is going to be confusing. If you go into a router and you're in interface mode, which is where you apply an access group with the access list with the access group command. If you type in IP access list, it'll actually dump you back to configuration mode, thinking that you are creating an access list. So there has to be a delineation because they're two separate functions. One is creating an access list, one is applying it. If you use the same command, it wouldn't work. Any particular reason you would suggest removing an ACL entirely rather than modifying an ACL? Yes. If you're in a circumstance where there is a potential to cut off access, particularly to yourself, to that router in the process of editing that ACL, or if there's a chance of, say, blocking routing or blocking some other traffic that you don't want to block, if you just do it on the fly rather than removing it and then putting it into a notepad, you can potentially block traffic off, and which can be horrendous depending on the circumstances. And I know because I've accidentally done it. So I would always recommend that if you're working with ACLs, even if it's a real simple one, take a copy of it off your router, dump it into Notepad, make the changes that you want, go back, and then, and the great thing about using Notepad is you can nest all your different commands that you want to use, cut and paste them at the same time, and within a few seconds, you remove the access list from the interface, you remove the access list, you recreate the access list, you apply it back to the interface. Happens within seconds. It's much faster for you to do it that way than it is to sit there and try and type it all out yourself. So I would always recommend, I always do it anyway, just for safety. It's more safety more than anything else. And yes, you can use the sequence numbers. That is an advantage of using sequence numbers. What I've found over with experience though is when you use sequence numbers, often things get put in and then they don't get pulled out again, and so you end up with a really messy, ugly access list. It tends to be more manageable and easier to keep it neat and tidy if you use Notepad and you keep the sequence numbers out of it. That's just the way it works for me. Certainly your mileage may vary on that. Can ACLs be used to redirect packets to another destination? Absolutely. If you use them for policy routing or formal policy routing, you can direct them, absolutely. IPv6 access list, no FTP to 11. What does this mean? IPv6 means it's an IPv6 access list. Access list means it's an access list that you're configuring, and no FTP to 11 is the actual name of the access list that you're creating. So that's what that means. So protocol IPv6, I'm creating an access list. This is the name of the access list. In the last example, so the IPv6 example, I'm guessing you're talking about the sequencing. Oh, okay, this sequence here. Okay, that's a sequence number. So in IPv4, where we put the sequence number at the front, in IPv6 we put it at the end, and we use the keyword sequence to add that sequence number. So again, we've got sequence number 20, 30, 50, 70, 90, 110. So it's just a sequence number. Same as what it was in IPv4, just added in a different way. Subnet mask on the ACL config, it's a wildcard mask. So it's no different to any subnet mask. But remember, it's the same as with routing, it's a wild. So when you type in your subnet mask for your interfaces, it's a wildcard mask. So it's a direct opposite to a subnet mask. So if you're trying to protect something that's on a /24 network, the subnet mask would be 255.255.255.0. A wildcard mask is the direct opposite of that. So it's 0.0.0.255 is the direct opposite. So you need to make sure that you're using wildcard masks on your ACLs. Can you re-emphasize where to apply standard and extended ACL rules, source and destination? So with a standard ACL, you apply it close to the source because you can only block on source addresses. So it's easier to block it close to the source. With an extended ACL, you block closest to the destination. Yeah, okay, worth mentioning the reload warm, it may be. So there is a command, I didn't want to mention that, it's not actually part of the CCNA curriculum, so it's not really hugely relevant to our discussion with respect to that, but certainly there are reload commands that you can enter in before you start mucking around with the access lists that will automatically reboot the router for you. If you stuff something up while you're doing the access list. But that's obviously got to be used diligently because you may not actually want that to happen. It might be catastrophic if you were to reboot the router for other reasons. For instance, there may be some issue that you're trying to troubleshoot. There may be some vital traffic that's going through at that particular time. There could be a corrupt iOS image that you're trying to fix, and the reason you're changing the access list is to give you access to do the TFTP for that image. Any number of reasons that you might not want to do that, but it's certainly a save your bacon if you need to. If you deny traffic in an ACL by default, they will prevent return traffic. Should traffic mirroring or IPS be used to allow the return traffic? Well, if you deny traffic in an ACL, there is no return traffic by definition because you're denying the traffic, so the connection isn't up and running. There are circumstances, there are circumstances where you can allow, depending on which direction you apply your ACLs, you can allow traffic through and then block the return traffic. But in general cases, you would work your ACL so that that's not the case. That's poor practice if you're doing that. So if you're allowing traffic to come through and then blocking return traffic, that's not necessarily, you shouldn't be doing that. You should be doing it so that that connection is never built in the first place at all. Even half open, it's just not there. So you could use traffic mirroring and IPS, I guess, but my question back to you would be, why are you trying to do that in the first place? If you missed an ACL line, you can add a new line later in your text, but with a sequence number in between the sequences where it's supposed to go. Yes, that's right. And this sequence it correctly in the access list rather than having to redo the access list. Yes, correct. You can add a sequence number in between existing sequence numbers. The only thing, as I said, that's a critical thing with that sometimes is that sequence numbers become cluttered and you don't get enough room in there to move around. So I don't tend to use sequence numbers that much. I tend to use Notepad. Is this ACL unicast reverse path forwarding in IPv6? I couldn't tell you without looking at it in depth, which no, I don't think that'll hurt my brain if I do that. So I think I'll just push on with that one.
All right, we wouldn't want that with the second bit to come. So
no, exactly. So I think we'll go. We should be able to get through this second part reasonably quickly. It's basic principles of hardening. So let's thank you for all those questions. All very good, and it's great that you're actually still paying attention at the end of 5 weeks of reasonably solid material. So it's very difficult to cram all this into a short period of time. So well done, everyone. All right, so we continue. Hardening iOS devices. So best practices would be to add password protection clearly, to enable SSH. So instead of using Telnet, use SSH. To configure login banners, and I'll talk more about those in a minute. Limit access with an ACL. So that's actually to the router itself, not through the router, but to the router. So I'm talking about VTY lines, Telnet, SSH access. Disable any unused and legacy services. So anything you don't need, turn it off. Such as CDP is a typical example you might turn off if you're interfacing to other networks or ISPs. Don't need it there, turn it off. Shut down unused interfaces to prevent physical access. Enable port security on switches. I say that tentatively, it's a Cisco recommendation, but I'm really not a fan of port security even now. When it first came out, it was a pig of a thing, and I'm not sure it's much better. But anyway, Cisco recommend it, so we go with that. Disable CDP, there you go, it was there. Configure NTP, so network time protocol, so that you know that you have a legitimate time on your router rather than just some random time that it will generate based on its iOS and hardware platform when it reboots. And configuring logging is another important component. Certainly events will be logged to the buffer on the router under normal circumstances, but that buffer is finite, limited by particular statements, but limited ultimately by the amount of memory available to the router, and it gets overwritten regularly. If you log things off to a separate server, obviously they're there for as long as you need them. Now it's really important. I want to mention the management plane, and I was initially thinking about doing all sorts of slides about control plane policing and all sorts of stuff, but I think that's probably going a little bit too far for the context of this course. But the management plane is really important to secure. So that is the plane of the logical plane of the router that allows you to access, configure, and manage the device. So it sends and receives traffic for the functions that are listed there. So for SNMP, Telnet if you use it, God forbid, SSH, FTP, TFTP, SCP, TACACS, Radius, NetFlow, NTP, syslog, any other DNS potentially, any other sort of processes you can think that would need to interact with the actual operating system on the router itself. It's really important that you secure them as much as possible because you don't want any turkey being able to log onto your router and do things. At the end of the day, if the management plane is exploited, then control of that device is lost and you're in all sorts of trouble. So passwords are a bit of a no-brainer. I don't even think I really need to spend much time talking on this. We all know the importance of passwords. They're standard and they're the required first level of protection. If you don't set a password on a VTY line, for example, you won't even get access to the router. It'll tell you to go away. It's a minimum of a secret password. The secret password is hashed, okay? And if you, it's a little bit out of scope, but a hash is really just a one-way cryptographic operation that turns a password into a string of hex digits. So what happens is when you type in a password, the router runs that hash over that password, compares it to the hash that it has stored, and if they match, then you've got the right password. Simple as that. There's a preference probably in best practice to use Radius or TACACS or authentication services. And simply use the local password on the router that's configured on the router as a failover if Radius and TACACS for some reason is out of action. So whether the servers are down or access from the router to those servers is down. The enable secret password, so that's again a hashed password that stops you, gives you access to the enable level of the router. So that's God mode in the router basically. Enable the service password encryption, because that will then make sure that all passwords that are entered into the configuration are not actually encrypted. I'm being a bit technical here, being a bit anal about it, but it's not actually encrypted, it's hashed. If you don't have that service enabled, then some passwords, like for usernames that you create or for VTY lines, those sorts of things by default are not, they're just stored in the config in plain text. So if someone happens to get random access and happens to see that, then they have your passwords, obviously. And passwords clearly should be applied to all your inbound lines, so your VTY lines, regardless of whether you're using Telnet or SSH. So basically a code snippet. So if we create a username with the username here, so that's username, whatever name, secret, and then we put our password. Now obviously when we enter it, it's in clear text. When we hit enter, because we have the secret code word there, it hashes that password, stores it in the configuration in the hashed value, so then it's no longer easily viewable. You can also lock out accounts from any iOS up from 12.3.14t upwards. Using those commands there. So that's just so AAA new model just basically enables authentication services, local authentication attempts. So AAA local authentication, so using local accounts, authenticating using local accounts, attempts, maximum fail 5, 10, 1, 3, whatever you want to put. And that will then lock out accounts if someone tries to do brute force attacks. We also have a thing called no service password recovery. This basically means there's a process you can use with Cisco routers, which is more of a CCNP construct, but anyway, I'll talk briefly about it here, called password recovery, where if you lose a password of a router, you can go through, connect the console cable to it, go through a series of steps, which involving powering down the router, powering it back on, hitting some keys. It'll bring you into a mode called ROM-on mode, which will allow you to boot the router without taking any notice of the configuration. Once you're in the router, you can easily get into enable mode because it has no password set, copy the startup configuration into running memory. That then reconfigures your router as it is normally, but because you're already in the router at the enable prompt, you then have access back to your router. So that's a process of password recovery. You can turn that off, so that's not possible. to do that. So if you lose the password to the router, there are ways in which you can recover it, but it's not easy. It's really, really difficult and a real pain. So I would use that command with care. Be really careful, but you can use that if you want to be super duper security conscious. It also prevents the config register changes. So the config register, once you break into the router, the config register is a register that you change to tell it not to run the startup config. So it just gives you a blank plate to work from which you can recover your passwords. If you do use password recovery, make sure you've got a backup copy of the latest config. Even if the passwords are hashed, you can download what they call decryptors, but they're not really, they're just reverse hashes that enable you to retrieve those passwords, but you can't do that with enable secret password. So if you've set up your enabled password as a secret password, there's no way to get that back. So if you forget it, bad luck. Okay, I'll just answer a question that's come up there on the side. Can you use IIII authentication with AD? Sort of. You can use any LDAP-based server with some versions of iOS, but in terms of standard ACL, AAA, often usually it's TACACS or Radius, which you can obviously get features of those, which can then talk through Radius or TACACS back to your Active Directory server. So it's not so much that you talk directly to AD, but you talk via Radius and TACACS back to your Active Directory, I should say. Okay, there are many useless services on Cisco routers by default. A lot of them are just legacy services that have been left there over many years, and they represent classic targets for enumeration techniques in particular. So enumeration techniques are just techniques used to discover what services are running on routers or any sort of target. And some of them are these ones. So these are actually the commands to get rid of them, but those are a range of some of the services that are enabled by default. Now again, it depends on the version of iOS. With many new versions of iOS and new router platforms, these services are disabled by default. So you can turn them back on if you want, but they're disabled by default. So things really old servers like Finger and UDP small and TCP small servers, a lot of those are disabled by default. So that's great. But there's still plenty of older routers out there running old versions of iOS, which you need to consider these particular services on. So to enable timeout sessions, that's an important point. And basically what these commands are doing is on the console line and on the VTY line, so telnet or SSH, they are basically saying, we're going to time out the connection in this many number of minutes and this many number of seconds, whatever you configure. Okay, and that should be keep alives, not keep alives. Basically, the idea of this is that ensures that remote end devices are still alive. So the service TCP keep alives in and out will make sure that the device that you connected from is still alive. And if it's not, those half-open sessions are then removed, thus freeing up access to the router or freeing up memory buffers. Loopbacks, and we spoke about these a little bit when we're talking about routing. The management plane, really important, really from best practices perspective, that you have access to the management plane through loopbacks, so both in and out of band. Loopbacks typically used for that in-band access. Out-of-band access is obviously through your console. And we do that to set up a loopback interface. It's just a simple question like that: interface loopback 0, IP address, whatever, no shutdown, brings it up, that interface is now then live. And you can do everything with those interfaces that you can do with a normal interface in terms of access control. And telnet, as long as the routes are there, you're advertising it as a route, becomes really easy to actually access that, like a normal interface. Console access, absolutely vital that we secure using password or authentication services. as we talked about with the VT Guidelines, and we need to reserve memory for it because that's useful when we troubleshoot. If we don't reserve memory for it, there are instances where the console can be swamped and you can't actually use it. It's useless. So very important that you reserve console memory for that. NTP, not a particularly dangerous service, but any unneeded or insecure service can become an attack vector. So it's useful to specify NTP services and restrict access from the router to those. So make sure that if you're pointing a router to NTP services, they're spot on. But definitely useful in keeping track of time when troubleshooting with logs. If you've got multiple routers that have different times on them, very difficult sometimes to match events up. Make sure you, of course, configure your time zone accurately. So if you're in America, for example, don't configure with an Australian time zone. Configure those time zone settings and configure authentication so that you know what you're actually getting. Encrypt management sessions. So this just means enable SSH. And there's a list of commands in the order that you need to write them to actually install SSH on a router. So you need to specify a domain name, in this case oldmate.com. You need to then generate some crypto keys. So we're generating RSA keys with 2048-bit keys. We're specifying a timeout of 60 seconds for SSH. We're specifying 3 authentication retries. So if you get a password wrong 3 times, sorry, babal, thank you for playing, you're gone. Our SSH source interface is Gigabit Ethernet 0, so that's the interface from which packets from the router will appear to come from. We specify a version, either 1 or 2. Go with 2 if you certainly can. We're enabling IP HTTP secure service, so that will then enable HTTPS for the web component of your management access to the router, should you want to use that. I wouldn't, but anyway, that's up to you. SCP server enable, then enables secure copy protocol for file transfers if you wanted to do that. And then lastly, we're turning on SSH on our VTY lines. So transport input SSH. Typically that, in other circumstances, you might put in transport input telnet. If you want to use telnet, I'd recommend you use SSH, obviously, because it's encrypted. Telnet is not. Console and auxiliary ports give you local physical access, minimum of AAA, so authentication or passwords, and an exec timeout. So don't leave them open all the time. And it's quite common to disable the aux port using that particular timeout, that particular code there. So line aux 0, no transport in or out, no exec, which means you can't run an execute shell. Timeout is 1 second and there's no password applied. So basically you can plug into the aux port physically, but you won't be able to use it. The aux port is actually valuable because you can use it as a console port or a reverse telnet. To use reverse telnet can be very useful in some circumstances, particularly if you need remote access to devices. VTY lines, as we said before, similar, secure similar to console, minimum of the AAA passwords and exec timeout, and ACLs to protect access to and potentially access from as well. And that obviously applies whether you've got SSH or telnet applied to them. Please use SSH, as I've said before. Just quickly, banners. In some jurisdictions, it is impossible to prosecute anyone who's illegally gained access to your router unless you have a warning banner saying, please don't come into our router unless you are authorized. And you outline those restrictions in some jurisdictions. And certainly don't ever have a banner that says welcome to blah, blah, blah. As soon as you say welcome, it's almost an open invitation to have a go. The legal requirements are very complex and vary between jurisdictions. So just keep in mind, I've heard of some CCNA exams that will ask a banner related question. So just keep that in mind. Seek advice when configuring one as well. Legal advice about the sorts of statements that you might be able to put into it, because sometimes banners make statements about things, about their jurisdiction and under what circumstances prosecution can occur, and they're basically blatant outright lies, so they don't stand up very well in court. So AAA, critical to use, not sue. You certainly don't want to sue your AAA server, they're very useful. So critical to use this framework to provide authentication, authorization, and accounting. So authentication, verifying that someone is who they say they are. Authorization, giving them access to these parts of the system that they are authorized to use. And accounting, keeping track of what it is, the resources that they're using. You can use TACACS or Radius for this, and basically you just set it up as we saw briefly before. AAA new model is the command just to turn on authentication services. We use the AAA keyword on all our AAA related commands after that. So we're using it for authentication, we're using it for login. The default we're using is the TACACS group, and we're going to turn it on. That's basically what that's saying, turn on TACACS for our authentication services as opposed to Radius. We then put in our TACACS server. This is our host. So that's our TACACS server. And then we then put in the key. So the key is basically what authenticates the router to the TACACS server, in simple speak. SNMP, so network management protocol, use later versions, say 2C or 3 preferably, and use complex strings. So by default, we have on routers, we have a read-only string, we have public set as the read-only and the read-write string. So public is read-only, private is read-write. Not great. So if you to set up, so my advice is to set up your own community strings. So read-only as the name of the string, wrong, too easy to guess. Read-only all hacked up like that, that's better. Still not ideal because it's still close to what the actual function of the community is, but it's better than nothing. And also best practice is to use ACLs to secure your SNMP access as well. So logging, last few slides guys, logging to host. So simply the command is logging host 192.168.1.23. That sets up the router to send all log messages. So those that are normally in the console buffer, it will send them to that particular host in question. Now, there's no real ability to access control list that. It's just logging information gets set off. You can also log to non-volatile storage, which is pretty cool. So you can log to your flash disk, more or less. You won't need to do this for CCNA, but I'll just add it in there because it's kind of interesting. So there's a couple of different ways that you can actually do that as well, but we don't need to cover that in any depth for what you guys need to know. Just quickly, I'm just going to mention data plane hardening. So we talked about management plane. So management plane is actually getting access to the particular router, the router processes itself. Data plane refers to the plane of the router or the logical plane of the router that is actually forwarding traffic, so forwarding the data. So some ideas around that: IP options, disable IP source routing, ICMP redirects, directed broadcast. The main one for you guys is CCNA level candidates, traffic filtering with ACLs. That's a big ticket item, and anti-spoofing. Unicast is really the main one. So stop from, so in other words, stop RFC 1918 addresses coming from directions in which they shouldn't come from. So say from the internet. Or if you know, for example, that out the fast Ethernet interface on your router, there's no way known you can reach the network 192.168.x. If you start seeing packets come in for 192.168.x coming from that network into that interface, you know something's wrong. So you need to be able to stop that from occurring. So that's basically what anti-spoofing is talking about. But the big ticket item that you guys as CCNA candidates have to worry about is your traffic filtering with ACLs. The rest, most of the rest of this stuff is next level. Okay, so next week, before you do the exam, review all your resources, go through your labs, look through the Zoom recordings if you haven't, browse the forums to check out what people have been saying. There's lots of really good backwards and forwards from you guys there, lots of really good value in that. and have a look at the practice questions for each week. Obviously, if you haven't already done them, you have to do them as hurdle requirements for the exam other than that week 2 test, but have a look at those anyway. So it's basically just go over anything that you haven't already looked at or anything you're not confident with. Now, before we finish up, I want to talk about the real Cisco exams just really quickly, but I'll answer some questions that have come up, then I'll talk about the real exams and answer any questions that I might be able to answer on those, and then that'll be it for this particular course. So let's answer these questions. Does a lot of ACLs on every port of a router have any effect on its performance? Only minor effect. So yes, there is always an effect when you add technology or mechanisms, but very, very minor. And remember that you can only have one ACL per protocol, per port, per direction. Vast majority of protocols now, you're going to be using IP4. Maybe some of you will be using IPv6, but generally you're not going to be running dual stack on the same interface. So minor impact on performance, but excellent question.
Looks like these next two are linked, Matt.
Okay, in Windows Server you can set up NPS role with support. Okay, yep. So that's true. Yes, yeah, they are. So Matt and Tristan, you basically said the same thing. You can set up NPS role which supports Radius, which integrates with Active Directory. Correct. Thanks for your comments, guys. Aren't loopback interfaces always enabled? When you initially create them, yes, but you can manually shut them down. So yes, I probably agree that a no shutdown command was probably superfluous there earlier, but they're not always up. You can manually shut them down. But yeah, you're right. If a loopback interface goes down, you've got something pretty bad happening on your router, particularly if you haven't done it deliberately. What sort of updates does Cisco have in regard to issues with SSH authentication? Yeah, SSH, yeah, well, not so much SSH having security flaws, it's more around the underlying algorithms, but they have updates all the time to simply answer your question. No different to any other vendor, so say Microsoft, they're releasing updates all the time. Which ones you apply are just determined by the functions that you're using and whether that actual update applies to the functions that you're using. So if you're not using SSH, for example, or not using the version of SSH which the patch is talking about, then you certainly wouldn't update it. But there's lots of different revisions of iOS, lots of different visions of iOS. So last one before I get into the next part, basic difference between TACACS, TACACS Plus and Radius, very similar. They're from a CCNA level understanding, not really that much different. They're basically authentication services. Radius is more of an open standard. TACACS is more proprietary. You're probably more likely to see questions revolving around TACACS because it's a Cisco brainchild, but basically the same. They have slightly different options and levels of authorization and accounting principles built into them, but that's not a discussion that we really have time to go into, unfortunately, but very similar things. Thank you for your questions. Okay, so now before we finish though, let's just have a quick look at the exams. So as we said way back in week 1, there are 2 tracks. Let's just close down these other windows. There are 2 tracks which you can take for the CCNA route switch. You can take the accelerated exam, which is 200-125. That's the exam number, or you can take the 2-part path. So 100-105 and 200-105. Either way, it doesn't matter. 2 exams. 1 exam still covers exactly the same content to the exact same level of depth. It's just that in ICND 1 and 2, they're split into separate parts. So you'll still get similar amount of questions overall, but you get to take 2 exams rather than 1. I guess the cynic in me sort of thinks that perhaps Cisco did it just to make more money, to enable you to take 2 exams instead of 1. And my browser is playing up. There we go, got that. I'll just click on this so we can go into it and have a little bit of a look. Oh, that's actually the course detail. That's not what I wanted. That's annoying. Sorry, I clicked on the wrong link. Sorry, guys. Come on, browser. So let's just quickly have a look at the exam details and then you'll see the difference. My browser is playing up this evening.
Always the way, isn't it?
Yeah, usually the way. But as I said, we've got horrendous, I don't know where you guys are, whether it's like this where you guys are, but I've got horrendous weather conditions here, which sometimes plays up with my DSL service. So you can see, for example, if we look at the ICND while we're waiting for the other ones to come up, that one's not going to come up, is it? The ICND 105 exam, 90 minutes, 45 to 55 questions. Okay, and then if we look at the exam topics, well, that's coming up. That's 105 there. Wow, it's really, I might actually be better just shutting that down and starting again by the look of it. Bear with me for a second, guys, because I think you might have some questions around about this.
No, that's all right. We're getting some good anti-NBN talk and woohoo copper and water from Justin.
Yeah, copper and water, exactly. That's been my problem here for quite some time. So is anyone, while I'm getting this back up again, has anyone got any specific questions about the CCNA exam that they could potentially want to ask? So pop them up while I'm getting this started. Hello. Sorry, it looks like my screen has just disappeared for you. Let's go back to that. There we go, got me back, I hope. Okay, nice question, Peter. Do we get extra marks for posting on forums? That'd be a no. Yeah, that's right, Matt. So Radius is standards-based, TACAX is Cisco, this is what I said. So, but there's a number of underlying differences as well in terms of some of the features that they support. Right, now we're getting on to things here.
So just to confirm with Peter's question on the forums, there actually is a participation mark for posting in the weekly forums. It's an additional sort of mark. It sort
oh, really? Oh, sorry, I wasn't aware of that. Sorry.
That's a new thing since your last short course. It doesn't count for those sort of comments that are just hi. So we do a little bit of filtering, but yes, there are marks for forum participation because we really do think that the chat and questions here and forum participation really add to the courses.
There's absolutely no doubt about that. In fact, I've been involved in some research studies with the university over the last few years, which shows that forum interaction by students can result in a letter grade higher in their final mark, rather than just viewing things. So it's a very interesting, it's an interesting point. All right, so this is what I was trying to get up. Although it looks like that one's going to 105 as well. That's rather annoying. So you'll see though, basically the same with 105 and 200 105. In 90-minute exam, 40 to 55 questions. So if you look at between, and then if you look at the accelerated exam, you've got 60 to 70 questions. So you have less exams if you go down, you have less questions if you go down the accelerated exam, more on the day potentially, but you have less questions overall. So in my opinion, it's actually a little bit easier, and it's probably better to get it in there and out of the way. The topics are exactly the same. There's no difference in the topics that they look at. They just split it into two. So ICND 1 is basically your layer 1 and layer 2 stuff, and then ICND 2 is basically your layer 3 and up. So they just break it into those two separate sections. So if you feel more comfortable in one area or another, you can take it that way. But the accelerated exam, for most people, I don't think there's any reason to not go down the accelerated path, to be honest. So we've got some, yep, okay, we've spoken about that one. Okay, there's a resource there for, okay, thanks, Matt. We might put that up on the forums. Okay, so here's some questions on the actual test. Are the labs enough for CC exam practice? Or do you refer any other source for lab practice? There's no, I can't endorse one particular set of labs or another. There's literally hundreds of them which are useful. But labs, in my opinion, lab time is really important for CCNA. You need to have some hands-on in entering commands and understanding what the syntax of the command is, because if you don't, when you get into the real exam, there are simulation questions where you'll be given a scenario, you'll be given a console window, and you'll have to actually write a command in. If you don't know the command, you're not going to get the marks for that question, simple as that. And that's sort of, it's not actually marked on the command, on you knowing the command or being able to enter the command. It's marked on, say you might get a question about spanning tree, so that it may be a physical command that you have to type in, but it's related to spanning tree. So that then will take marks away. If you don't know the command, you haven't had experience with it, you don't know what it is, then that's going to take away from that particular topic, your spanning tree. So it may be that you know spanning tree really, really well inside out, but if you don't know the command to run whatever the feature is they're asking you to run in the test, then you're going to fail that particular topic, or you could potentially fail that topic. So the labs, the packet tracer labs that we provide as part of this course, they will help you get towards your CCNA certification, but I would expect that you would need a minimum of 3 to 6 months of hands-on experience with more lab equipment, preferably real equipment, because you can't learn everything off a packet tracer lab or a simulated environment like with GNS. Well, GNS3 you can, because it runs real iOS, but with most of the simulations, they're not a real iOS platform, so it's difficult to get the real exposure to it. Which major areas should we focus on preparing for knowing full well CCNA? The only answer to that is look at the blueprint. So look at now it's coming up. Look at the exam topic. You have to know everything on this list. There is no, I can't sit here and say, only look at this, focus on this particular area. You have to focus on all these areas. You have to know all of these areas reasonably comfortably. There are some that are probably less likely to appear on the exams, but remember, the exam is an adaptive exam. So what that means is that's why it says 60 to 70 questions. So you will get a minimum of 60 questions, but you may get up to 70, because what will happen is, say you're in the WAN technologies, a question comes out about WAN technologies, and you answer it incorrectly. The system will generate another question from that topic to try and drill you again on that particular topic. If you get that wrong, it might give you one more. If you get that wrong, it'll say, okay, this person doesn't know anything about WAN technologies. But see, there's 3 questions that are hit in there. Okay, so that gives you an extra couple of questions. If, however, you get one on WAN technologies and you nail it the first time, and it's graded as a more difficult question, if it's a scenario question and you nail it, you might not get another WAN scenario question. They might just go, okay, this person knows enough about WAN, I'm happy with it. It's based on think of it, the number, a rough guide is you look at these percentages here. So you could reasonably expect that around 10% of the questions will be on infrastructure management. So that's around about 6 or 7 for security, around about 6 for services, around about 6 for WAN, double that, so around about 12 to 13 for router technologies, 12 to 13 for LAN switching, and somewhere in between, around about 8 to 10 for network fundamentals. But that extra, so that might make up your 60 questions, but you've got an extra 10 there that you may potentially be asked if you're getting questions wrong. So they'll retest you on a certain topic until the testing engine is satisfied that you understand that topic well. So the answer is there's no main area for you to focus on. You really have to be across everything. Does a CCNA get you into a networking role, or would you need a few years experience? Look, again, that's a difficult one to answer. It depends on who you are applying for jobs through. A CCNA may get you a role, it might get you an entry-level role, or it may not. Some companies I know of want, CCNA and they want 5 years experience with that, which is, personally, I think it's ridiculous, but there are some companies that do that. Other companies might say, well, 2 years of experience, but I want you to have a CCNP instead. And then you might get others which will say, no experience necessary, but I want you to have the CCENT, which is a real base level certification. So there's no real way to give you a guaranteed answer on that. It certainly won't harm your job prospects, but it won't guarantee you a job. There are certainly no guarantees. When in the CCNA exam, about 10% of the questions, according to the blueprint. So you could think between 6 to 7 questions, or maybe up to 10 if you're getting them wrong, will be on WAN technologies. Do you know how the answers are graded? No. I can give you, not explicitly, some of the answers at multiple choice questions basically assigned a certain weight, and what that weight is I couldn't tell you, but it's a lesser weight than, say, a scenario question. There are drag and drop questions which are also a different weight. There are CLI, scenario-based questions, which are, I believe, the highest weight. So there's a number. Basically, the final score is out of 1,000, and your cutoff score will be dependent on your exam and what Cisco have set that cutoff score at. But typically, it's around about somewhere between 68 and 75%. So between around about well, not really percent, because 1,000 isn't really based on a percent. It's based on the weighting of the questions in the topic. So the score is usually somewhere between 670 and 730, something like that, out of 1,000. But that doesn't equate to a specific percentage. It's based on question weight. Thank you for that question, Phil. The answer is no. So in terms of what exam I would suggest you do, my recommendation is always to do the 200 125, so the accelerated exam, but it depends on your background knowledge. This course will give you a lot of the background knowledge that you'll need, but whether you'll be able to do it in a month from now is impossible to answer. It depends on your learning style, how well you absorb material, how much hands-on practice you've had with the packet tracer labs, what your other experiences are, what your background is, whether you've always been a network or you do other stuff as well. It's too difficult for me to say definitively whether you'll reach that goal within a month. Impossible to say, so I'm sorry, but I would generally recommend people go the accelerated version. I actually think that's easier than going the 2 exam version. Okay, can you go backwards and forwards through your questions? Last time I did the CCNA exam, which was quite a while ago now, and I haven't needed to do it. No, well, when I say quite a while ago, I do know people that have done it recently. No, you can't go back through your questions. You just have to answer it and move on. Once you've answered a question, you've answered it, that's it. Do I encourage writing CC up front without CCNP after passing CCNA exam. You don't need CCNA to do CCIE. You can do the written CCIE test up front. There is no requirement for any certification going into CCIE, but having said that, it's going to be hugely dependent on your experience. Look, I know people that have done CCIE just using lab equipment, have never actually had hands-on practical experience with a router in a real environment. They've only used lab equipment. It's been real routers and switches, but only lab equipment, and they've got their CCIE. But even guys that, they take, one guy in particular took 18 months of basically studying 8 to 10 hours a day, 5 days a week to get to that stage. I mean, there's too many variables to say who's going to pass the CCIE in how quickly, in how many attempts. It's just impossible to say. It's dependent on so many other things. Would I encourage you to do the CCIE up front? Depends on your experiences, depends on what your background is. I can't answer that without having that information. Is it doable? Yes, it's been done before, absolutely. I didn't do it that way. I went through CCNA, then CCNP. I like the idea of going through the Cisco curriculum and doing it the Cisco way, but you certainly don't have to do it that way. Once you get past that, once you get the CCIE route switch to go to the next one, security, for example, you would just go for the CCIE. You don't have to go through it any other way, because once you've gone through the process the first time, you understand what it's all about. It's a little bit easier, I guess. You fail if you still score 79 out of 100. Well, it's out of 1,000, but possibly it depends on what the cutoff score is for Cisco. So again, it doesn't equate to a percentage. It's based on the weighting of the question. So don't think of it as being a percentage, because it's not that at all. Any highlights or other topics from here? Recommendations, security and wireless. There are, as I'm sure you've seen, there are, what am I doing? There are lots of different flavors for CCNA, and my browser looks like it's decided to crap itself again. There are lots of different flavors. Probably the hottest ones at the moment, from what I can see, would be wireless, security, and potentially voice related. But you can see here they've got, back in the day, there was routing and switching and that was it. But now there's, stuff everywhere. So sorry, voice is more around collaboration now. There is no voice anymore. Wireless is always a cool one. Security is definitely a cool one. Security is always going to be hot. Routing and switching is basically the one you start at if you're not sure what you really want to do. So it's a bit like a Bachelor of Arts. Go down that way if you're not sure what you want to do. It gives you a good qualification, but it's a starting point. And then the rest of it is really driven by which way you want to take your career or in what part of the industry you're working. So as I said, security is always hot, always a good one to look at. Service provider is obviously very niche. If you're working for a service provider, it's great. There's some real specialized equipment you need access there to get down that track. So if you're in a service provider environment, great. If you're not, probably a bit too difficult to get. Wireless is a good one. Design is good if you want to become an architect, which is the highest level certification you can get with Cisco. Incredibly difficult to get, and incredibly involved, but you obviously can do it. Data center, again, you need to be working in that sort of environment. Cyber ops, collaboration, cloud, you need to be working in those sort of environments to be able to achieve those sort of certifications in a timely fashion. And to make it easy, because it's always some of these flavors. So security, for example, you need to have access to ASAs and IPS and Cisco security kit. If you don't, there's no real way to lab it, and not a lot of the virtualized environments or lab racks will actually give you access to that specific equipment. So you really need to be working in that area on real kit to be able to go particularly to CCNP level, but even to CCNA level in some cases. So the way I'd go if I was doing it all again, I'd go through the route and switch track as far as you want to go, whether it's CCIE or just a CCNP or just a CCNA, it doesn't matter, depending on your level of job. But then if you're looking at doing a second one, certainly my money would be on security first if you were just working in integrator space or enterprise land. If you're working specifically for a service provider, you might go straight into that. So it depends on obviously what your requirements, goals, and achievements are. So okay, so that looks like that's it for the questions. Anything else you would like to add, Guy? Or is there anything else we need to do before we sign off? Okay, Guy looks like he might have dropped out. Okay, so that's pretty much it for us. So thank you for attending this short course. Hopefully it's been of interest to you. As Guy said at the top of the show, please take some time to look at the Moodle portal and provide us with some feedback on the course and what you thought of it, and particularly on the Zoom sessions, because obviously that's going to be important for us. But otherwise, thank you very much for your attendance. It's been a pleasure. I hope you've enjoyed the last 5 weeks. Good luck for the exam. If you want to put any questions up about the exam, feel free to post them onto the forums as well as we can answer them. So Guy, I think's back. Is there anything you want to add, Guy, before we sign off?
I'll just do a quick test. Can you hear me?
Yes.
Beauty. I just want to thank you, Matt, for tonight and your generosity with your time with the questions here tonight and over the whole course.
No problem.
Also, just want to briefly thank Robert Hudson from ITPA and Jason Howarth from CSU for presenting in weeks 1 and 2. And importantly, thank you all listening live or later on in the recordings and participating and helping ensure that future short courses are developed. If you need any information on short courses, it's all on the course page, so have a look there before sitting it. I hope you've all enjoyed the course, and yeah, just once again, thank you very much, Matt. I'll hand you over to bring us to a close.
All right. I think the only thing I want to say now to wrap up is just say thank you to you for emceeing us for the last 5 weeks and helping out with questions and chat and all sorts of administrative things. It's made my job a lot easier and allowed me to focus on what I needed to do and hopefully deliver some good content to the students out there. So if you've stuck with us for the whole 5 weeks, well done. There's been a lot of content. And there is a lot of content in the CCNA. It's a very, very broad certification, and it's really difficult to jam all that detail into 5 short weeks. So I hope everyone's got something out of it. I wish you all the best for your future careers. And if you go ahead and do the CCNA certification exam for real, I wish you all the best with that. And by all means, feel free to drop back into the Moodle site and post on the forum and let us know how you go with the Cisco certification exam if you get around to it, and let us know how you progress with the certification streams. But otherwise, that's it from me and I think from Guy. So thank you very much for your attendance.